So let's just quickly answer that question. When is a function linear? Um, a function is linear when the ordered pairs when graphed make a line. Okay. Ergo the name linear functions. Now we're not going to have the luxury of having graph paper to graph these, and sometimes the points will be so far apart it's going to be hard to tell. So we're going to use the following facts. Write this down. Linear functions have a constant rate of change. Keywords here are constant rate of change. Okay. And the other fact is solutions. And this is what we're really going to be focusing in on in this unit. Solutions to linear functions are ordered pairs. So when we're talking about ordered pairs, it's x comma y. Okay. So we're going to be dealing in ordered pairs. Okay, so we'll do just two examples. We're going to determine if the function is linear. So we're going to determine if the function is linear. So I'll just give you a function. All right. Let's say I'm going to make a table, two columns, one for x, one for y. All right, x and y, there we go. And I'll give you some numbers. So this is going to be a function. We don't have to determine if that's true. Okay, so here's the values for our function. The domain is going to be -8, -4, 0, and 4. And the range is going to be 6, 3, 0, -3. Okay, so go ahead and make that table. And while you're looking at it, I hope you can see that it is a function, right? None of the input values, the domain values, repeat. We have one -8, one -4, one 0, one 4. Okay, so our goal is to see, do we have a constant rate of change? Do we have a constant rate of change? Um, I know we did this last school year. Do you remember how we find, when you have a table, how we find a constant rate of change, or if we have a constant rate of change? Well, what does change mean mathematically? Are we adding, subtracting, multiplying, dividing? Yeah. Basically, we want to determine the change in the y values over the change in the x values. You remember that little triangle means difference or change? So we want to find the difference in y's divided by the difference in x's. Um, difference in y over difference in x. Okay. Well, let's start doing that. Let's find the difference in our consecutive x and y values. So let's start with -8, and we're moving to -4. We're clearly going increasing, right? How many places are we going up? Okay. Let's try again. -4 to 0. How about there? Okay, this is looking promising. And then 0 to 4. What's that? 4 again? All right. Let's do this one. 6 to 3. What's the change here? Well, is it an increase of 3 or decrease? And looks like we have same thing here. 3 to 0, we went down three more. 0 to -3. What are we doing there? Okay. So it's looking pretty good. Let's see what our change in y over change in x. Change in the y values over change in x values. So if we look at the first pair, it's -3 over 4. If we look at the next pair and the next one, all of them are constant. So what conclusion does that give us if this is linear or not? Yes. We have a constant rate of change. So the function is linear. And we lucked out on this one because sometimes you're going to have some where it's negative 3/4, and the next one might be negative 6/8. But when you reduce negative 6/8, it's negative 3/4. So just because they're not equal like we got these on the first go around, after you reduce them, if they are equal, then you can say yes, they're constant rate of change. Okay. Any questions? All right. So the second and final example. Let's say I give you ordered pairs in a set. -6, comma 3, -3, comma 3, 0, 0, and then the last one is -3, +4. So this time I'm giving you a function that's as a set. But this is still xy. So easiest way I think of doing this is just make it a table. Think of it as a table. So back to a table we go. Okay. This is x, this is y. I'm going to just make my table with these. Okay, so I made my table, and now I want to see what the change in the y values is, or the change in the x values. Okay. Okay, so let's see here. -6 to +3. We're increasing by 3. Okay, let's see what we have here. 3 to 3. What's the increase there? 0. So we're going to start off with 0 over 3, which is a 0. Let's see what the next one gives us. -3 to 0. Well, this looks good because it's also increasing by 3. But if I go from 3 to 0, what's that going to be? Yeah, we're decreasing by 3. So now this other one is 3 over negative 3, right? Oh, other way around. Yeah, negative 3 over 3. Negative 3 over 3. What I was doing in my head is I was reducing this. Isn't negative 3 over 3 just negative 1? Which is not 0. So I have an issue. This is equal to 0, which is not equal to negative 1. This is going to give me 0. This is going to give me negative 1. They're not constant. They're not equal. So you could just stop right there. Once you hit something that isn't going to give you an equivalent fraction or equivalent number, and just say, this isn't linear. So no constant rate of change. Oh, CR. No constant rate of change. So not linear. And we could just stop there and say, nope, that will not form a straight line when we graph it. Okay. So basically we want to determine, okay, do we have a linear function or not? And the way we're going to do that is by finding the change in y's over the change in x's. Okay. And that's the assignment for today.